Hi friends, the next issue to look at is once the statistical model is defined, now we need to see how this model can be fit using the data. So how to fit the data to the statistical model is the next issue to look at. So this process involves finding the parameters of the model that best describes the observed data. Now, as we have seen in the previous case, there are many statistical distributions available, a probability distribution available. So, if we know that our data given or the data set given has a normal distribution, then fitting the data to this statistical model. Here the statistical model used is a Gaussian distribution and it has got two parameters. One is the mean and other is the variance. So here the fitting data is a process which involves finding these parameters of the model that best describes the observed data. It is a process that aims to create a model that captures the underlying patterns, relationships, or distributions in the data. So, the steps for fitting the data to the statistical model. First thing is define the model. So, assume what type of distribution the data may have, then decide what all the parameters are required to define this model, and then define the objective function. So here the objective function is something to do with finding the error between what is assumed and what is observed. So if the assumed is same as what is observed, then the error will be minimum, and if the assumed is different from the observed, there will be an error. So the whole objective of this fitting data is to ensure that the error is minimized. For finding the effectiveness of the fitting, we need some estimation methods. So these estimation methods do find the error between the reality and what we are assuming. If they are the same, if we hit on the nail, then the error will be zero. If it is not the correct one, then there will have an error. How do we measure the error? So the error may be measured using the least squares error. So that means the at every value, just find out what should be the real one and what exactly we are getting. The difference of them is found, and it may we are talking with multiple data, therefore the error gets, we need to add and to make it a single value, but the errors may be positive, negative. So to make sure that these errors do not cancel each other and make it zero, so we just remove the square. The simplest way of remove the sign, the simplest way of removing the sign is square the difference. So that's squaring the distance and differences and finding when it gets minimum. So talking about least square. The other way is the maximum likelihood estimate. So here we just try to estimate the likelihood of the parameters and try to find the maximum of that, and so that the model fits the best to it. Or we have Bayesian methods. That means the Bayes method, Bayes theorem is used for doing that. So in statistical world, Bayes theorem is one of the best way to solve for the unknowns. So always we prefer to work with the Bayes theorem. So most of the problems are easily solved through Bayesian techniques. Then we try to optimize our overall process and then evaluate the model we had selected and then validate. If the validation is not satisfactory after evaluating the model, if we are not satisfied with the result, then iterative refinement for the model is done, and finally the process is interpreted for the actual results. So fitting data to a statistical model is an iterative process that combines a statistical theory, then we have computational techniques, and we do require domain knowledge. Fitting data requires careful considerations of model assumptions and an understanding of the context in which the analysis is conducted, and it is essential to balance model complexity with interpretability and avoid overfitting the model to the noise in the data. So there is word overfitting. So we just look at what this is in detail shortly. Yeah, we have come there. So the challenges in model fitting, there are two challenges we have. One is called underfitting and the other one is called overfitting. Underfitting. In this case, we define the model very simple, and the model is too simple to capture the underlying pattern or the relationships in the data. So we try to use the simplest mathematical model to correlate the input and the output, and because the model is simple, it may not be able to understand the total patterns in the data, and this often leads to poor performance in both training as well as testing. That means while training, the training will not be perfect because the data, if it is too complex, then simple model cannot be used to train the data. So the response will be poor while training, and because the model has not understood the data correctly, so it won't be able to predict the outcome for any new data. So the performance is poor in both training as well as testing. It's unable to adequately represent the complexity of the true relationship. That's what we were talking about. It because it's very simple, so it's not possible to represent the overall complexity of the situation, and predictions are always inaccurate, and effectiveness of the model is very low. The characteristics of underfitting: if the model is underfit, then we can understand it through these characteristics. So one is poor training performance, there will be low accuracy, the model will have a very simple structure, and there is very high bias. So the bias is one which talks about the performance difference between training and testing. So for training it shows one performance, and for testing it shows another performance, and the difference between these two performance is what the bias is. The best model is the one which should have minimum bias. That means irrespective of whether the results are known, that means the training data, or the results are unknown, that is the testing data, it does give the better or the best performance in both the cases. That's what we are interested in. But here in the underfitting case, what happens is for the training it will get a low performance, for testing also it will get a low performance, and the results are so different that the bias is very high. So why does a model uh, gets underfit? So the first thing is we do try to use a simpler model. So we don't want a complicated model, because the more complex the model is, the more time and effort is required for training it, and the more efforts are required for testing it and all that. So we would like to simplify our work. So in that, what we usually do is keep our model as simple as possible, and that becomes a cause for underfitting the model. Another major reason for model being underfit is insufficient features in the data. So the data is not having sufficient features to allow the model to understand the patterns underlying in the data or the relationships in the data. Then it won't be able to uh, train, so therefore the model remains underfit. So there is something called regularization. So this regularization will make a boundary for training, and if it is highly regularized or over regularization is done, then the training is done under very uh, what you can say, where lesser space is allowed for training, and hence the model will not be allowed to see the whole world, and hence it remains under fit. One of the most common reasons for model being under fit is insufficient number of training data. The more data we have, the better possibility of finding the patterns inside the data. So the higher the number of data or the larger is the data set, the better possibility of model being created. But when in reality it is not may not be the case that every time we get a large amount of data. So in that case, the model will not have sufficient examples to learn, and hence it remains under fit. So how to address this? So one, improve the complexity. So instead of having a simple model, try to build a little more complex model. Then we were saying that relevant features are not sufficient, then try to add more relevant features. We said that over regularization may be a reason for that, then reduce the regularization. So another reason we had quoted was availability of training data is less, therefore try to collect more and more data. And next is the model selected may not be suitable for the problem, then why not try with different models and see whether another model is better for the given problem. So try different algorithms for that. On the other side, there is a overfitting. Here the model learns perfectly what is taught to it. That means it learns the training data perfectly. In doing so, any noise is there, any error is there in the training data, the error, noise, randomness, everything is perfectly learnt. So it doesn't discriminate between the real value and the noise and all that. So whatever it is given, it perfectly learns. Instead of understanding the underlying pattern, it just tries to remember input output relationship, point by point, everything. And this sometimes becomes a problem, and it will perform perfectly well on the training data but fails to generalize effectively for any new unseen data. So that means for the training the results are excellent, but for testing results are very poor. In case of underfitting, training as well as testing results were poor. Here the training results are excellent but testing results are very poor. So that is the what we call overfitting. And the overfitting leads to poor model performance and inaccurate predictions. The characteristics of overfitting: we get a excellent training performance as we discussed, and we have very poor generalization. That means whatever input is given for that, it will give perfect answer. It's something like mugging up a given answer for any given question. The question answers are mugged up and exactly the same question is asked, then word by word every part of the answer is put on the paper. That's what happens when we are overfit. That means training is done with a overfit model. That means we make the student uh, remember answers to every question instead of understanding the topic. So understanding the topic is something to do with generalization. So if you understood the topic, then if the question is modified, the same question, if it is asked in any other way, then also you will understand what is being asked and you can answer it. It's not necessary that the question need to be totally different. The same question, if it is reframed in different way, then you will be able to understand that the same question is being asked in some different way. So you can reproduce the same answer which you could have given for the other question. So that's generalization. But if it is overfit, that means if you just remember answers to every question, then if the question is asked little differently, you will not be able to make out that this question and the other question what you have mugged up are same. Therefore, you will not be able to write that answer because you don't understand to which question this particular thing belongs to. So it will not be possible to generalize. So we get a poor generalization if it is overfit. And another problem is this model will be too complex, so it is too costly for training as well as testing, and this will have low bias and high variance. So low bias means the training will be perfect, so that is a low bias, and the performance for the training set as well as testing set are totally different. Therefore it will have high variance. In the previous case, the training and testing both were poor, so the bias was high. So the causes for overfitting: excessive complex model, too many features are there, small training data set, overfitting to the noise, lack of regularization, data leakage are some of the reasons for overfitting and how to overcome them. So instead of having too complex models, so try to simplify it little bit. Then instead of having all unnecessary features, use feature selection and use only those features which are useful for our problem. Then add some regularization, then use cross validation technique to increase the number of for the given number of data. You can just use a technique called cross validation. So even with a small amount of training data, it appears that we have very big amount of training data through this process called cross validation. Even we can create the data through the process called data augmentation. So like as an example, if the data is a form of a figure, then the figure need not be always perfect. The camera is not always perfectly aligned while taking a picture. So most of the time the camera will be randomly aligned. So we want our model to recognize all possible orientations, all possible zooms, all possible disturbances and all that. So in that case, what we can do is for whatever data is available, so we just modify that and we just rotate that by some angle, clockwise, some angle, anti-clockwise and all that. So through this what happens is various number of data can be reproduced from the same data, and all these data can be used for training. So through data augmentation, we don't have to search for new data. Whatever data is available, from that we can create new data set and continue using. Another way of addressing this is using ensemble methods. Instead of working with a single model, try to use multiple models and then use the result of all the models and then do some way to find the results. Like if you are talking about classification, then use multiple methods to solve this problem and solve the problem by all these methods simultaneously and collect the result from all these models, and whichever result is voted maximum will be the answer. So if it is a binary classification like problem, then if there are some say 10 different models are there, each model will say yes or no, then count how many yes are there, how many no are there out of these 10 outputs, and see which gets maximum vote, yes or no. So whichever gets maximum vote, that will be the winner. So that way, instead of depending on one model, you can depend on multiple models, and all models together can decide the result. So that's something to do with the ensemble method. So if data augmentation, cross validation and all these are not sufficient to solve the problem, then the only option left is collect more and more data for creating a more accurate, properly fit model. So that's these are various methods to address the overfitting. So at all, we have data, we understand the patterns of the data by statistical modeling. The model, if it is too simple, then it may not give better performance, so it is underfit. If it is too complex, then also it will not give better performance, so it is overfit. What we want is something best fit. That means it gives the best performance for both training as well as test data. So that's all for now for this session. And oh, we have come to the end of module 1. Let's get into module 2 shortly. Till then, keep watching. Thanks.